Ever refresh a dying site during a sale or a vote? We see web servers crumble under traffic daily and companies spend millions on fighting DDoS attacks. But what if we could outmuscle floods? So let's break them down. Ever wondered writing web applications in C++? Well, that's just as good as a possibility as writing in any other modern managed programming language like Java or Python. After a little digging through the developer social media, also known as GitHub, two names surfaced: NodePP, which is a lean async beast of a server, and NodePP Express. It is an Express.js inspired sibling, not that shiny in performance, but definitely showing great potentials. Now, these both web frameworks offer little to no dependencies, native speed, and survival. What's better? They're cross platform with all of them working on all Windows, Mac, and Linux, which I tested myself, and you would also see that in a moment. So let's get started. We'll start first with NodePP. This is the GitHub repository for NodePP. We'll clone it, git clone the link we pasted. Okay, so now that it's cloned, let's open it up. So this comes with a sample application in src directory. npp app cpp is the one which contains the application code. If you take a look at the README, you can see the different ways this library can be used. How you can specify route, how you can specify the API handlers. So what it says is in the src directory, application sources needs to contain at least npp app h and npp apps.cpp with npp app main inside. So this becomes our entry point of the web application. We get a simple 4-page application included in the package inside src directory npp app.cpp, which we are looking at right here. We haven't configured our language over yet, so we are getting these errors. We need to specify the include directories and we will be just fine. Well, let's give this a try and build and run this. So there are two scripts inside, m and Windows equivalent patch file, and T and Windows equivalent patch file for that as well. So if we click on this doc link, get started on Linux, we see that we need to run m to compile and T to run. So we will do that. Let's switch over to the src directory. Okay, we are inside NodePP src. Let's run m and then T. It's making the app. Let's wait while it finishes. Alright, so the server is up and it's active on port 8080. Let's head on to port 8080 in our web browser. 8080. This is the web application which we are running from C++. So it's a native application running directly on your CPU without any kind of runtime environment at all. Something which you get if you're running a web server in Java or some other managed programming language like Python or C#. Alright, so what it says, congratulations, you have managed to compile and run Node++ web app. I hope you will like the performance of the compiled code. You're on desktop, right? Okay, so it also identifies the kind of platform which I'm running on. Here is a simple form. Links probably to some files as you see at the bottom. It's at path welcome, snippets, and performance. These are also present at the top navbar over here. Let's go ahead to welcome. Okay, so it's a form. Say something about yourself, name, developer, age. Well, it's asking for my age, 25. Submit. Welcome developer, my dear friend. It's good to see you in good health despite being already 25 years old. Okay. Ouch. Let's head on over to snippets. So we can see different kinds of formatting applied over here. Emphasize text, bold text, italics and underline text, ordered at unordered lists. There's different kind of font as well. If you look on the performance tab, based on 7 requests, the average rendering time is 0.681 milliseconds. It seems that Node++ application could handle up to 126,955,205 requests per day on your server. Well, that seems to be pretty good number. Refresh this page a couple of times to obtain more accurate estimation. Well, let's do that. So the numbers have, I guess, increased. That is really good. Average rendering time is clocking around 0.2 or 2 milliseconds, which is not bad at all. Alright guys, so let's move on from NodePP to NodePP Express. This is an Express.js inspired sibling, but in the C++ world, it has a very similar syntax to Express.js, so the way we create a server and the routes, as you can see. Well, for the purpose of this video, we'll not actually go ahead and clone this repository directly, but we'll actually use a fork of this repository, my forked version in particular. The reason why I'm using my fork and not the original repository, because the original repository actually ties in an expectation of you to have the dependencies already present in your machine, as well as NodePP setup. The NodePP which we are talking about here is not the NodePP which we just saw. It's another NodePP. Well, let's quickly show that. This is the NodePP, which NodePP Express is built on top of. So it is a different repository, but definitely owned by this NodePP official project or GitHub account. The one prior to this, which we discussed, was Recmus NodePP. All right, enough talking. Let's get back. So I'll go ahead and clone this. Well, we need to be in VIP at CMake branch, and we need to do a recursive clone because, as I just said, the original repository and this fork differ in the way we have, or rather I have set things up. So I've integrated CMake with it, so building is much easier, and the vendor library, the vendor folder contains the libraries NodePP and zlib, so you don't have to set up everything for yourself. There is another library, OpenSSL, which you need a dependency of this NodePP Express, but I'll attach links in the description from where you can download it and set up. It's really very easy to set up OpenSSL. So let's go ahead to our terminal, do a git clone recursive, and the link we just copied. Now we need to git checkout web add CMake. Obviously we need to be in the correct directory, which is NodePP Express. Git checkout again. We switch to this branch. Now we need to see if we have actually the vendor folder to, yeah, if we have content inside NodePP. We don't. Well, this is I don't know why, for some reason git clone recursive did not actually clone these. Maybe because this was in a feature branch and we did a git clone recurse on the main branch. Whatever be the reason, we can quickly fix that with git submodule update --init. As you can see, the libraries are now being cloned, NodePP and zlib. We'll give it some time to finish. Alright, so now that our submodules have been checked out, let me just verify the contents. NodePP, yep, they're there. Zlib, as expected. Let's clear the console. Now let's build this. So what we have is CMake list, I believe. Yeah, we have that in our root directory. We'll run the build script, build and run maybe. Yeah, why not? So while that is building, let me open up NeoVim and I'll show you code which we have got. Alright, so now while that's building, let's open up our editor and let's go over the code which we have got. NodePP Express, SASE, main CPP. Alright, so this is what we have over here. What you can clearly make out is we first, in the onMain function, declare this express http add method. We get an app, then we attach a middleware to it, something which will be called before handling all of our API requests, sort of what the concept of middleware is. Now this is how we define the API route test and the handler for it. The handler is the lambda which is provided as part of this get function declaration. Similarly, for when the case there is no path specified, we want this to be the API handler. Now all we need to do is app listen the host name, localhost, and the port number. Any other code which we need to run alongside with app listen. So what will be running when the application starts? It will be showing console log server started at and HTTP localhost 8000. So what you can see, it's all giving like JavaScript vibes, but in a C++ flavor of its own. So Well, C++ is a language with a lot of variety. You can practically do anything with it. Let's go on, check if our build has finished, and it is. Build debug server not found, obviously, because okay, so we'll get to that later. Maybe that's not important for this video. Let's build the server. I mean, run the build server. So the server started at HTTP localhost 8000. Let's open it up. As you can see, we get hello world printing, but in a browser window. So our server is running up nice and tidy. The API route which it is serving is this, since we didn't provide any kind of route over here, so the default one got picked, and hello world. It's basically Express.js but in C++. So Express CPP maybe. Let's check this out by calling the test route. So test, this is a test. As you can see, gets printed. That's exactly what we sought out to do. This is a test. Well, if we look at the readme, if you look at this part, we can also inline some HTTP and render this. Let's try this out, but for this, let's do something exciting. Let's head on over to React tutorial. This is a tutorial website hosted by React, I guess, and it follows you through a tutorial of making a tic-tac-toe game. What we are going to do is not spend time into learning React in this video, but actually get the final build product. From what I remember last I saw, this gives an entire single HTML page. We'll go ahead and download it. So this is the sandbox HTML which we got. Let's open this up. It is a single HTML page with this stuff going on around here, the tic-tac-toe game. What we'll do is we'll copy the entire HTML inside of this. So we'll do auto react maybe, and then goes our entire HTML page inside of here. So we opened the sandbox HTML in our editor. We'll copy the entire thing. We'll go back to main.cpp. We'll paste the entire thing. We'll save it. Maybe I can add a route app.get. Or let me just copy things. It will be much quicker and easier. I'll specify we need this to be on game route. We'll be modifying the header. We'll be sending text HTML, and now we'll be rendering stuff, and inside our parentheses we'll provide the React page. Let's shut down our server, build this thing up again. Now let's run the server we just built. Server started. Let's go back to this page. Let's type in game. And so now we have got this tic-tac-toe game running, all from our web server which was built in C++. Well, obviously this works as expected. So X1, and that's there guys, web development in C++. How cool is that? Now let's put these two servers up for some test. I'll open up a terminal and we'll use AutoCannon to do some testing on both of our web servers, NodePP and NodePP Express. Let's get on with it. So I'll also start the NodePP server. We'll run making npp app, and the server started on port 8080. Just making sure we have got it right. Okay, it's working. So let's use AutoCannon, which is a utility which we can use for stress testing our web applications. We'll specify a concurrent number of requests to be 100 by the -c flag. We'll specify the duration of the test by the -d flag. We'll specify local host 8000. Let's check on the 8080 port, which is where our NodePP application is running. Let's test the NodePP application first. It's running a 10-second test with 100 connections. Pretty impressive. So the average latency which we see around is 5.4 milliseconds, the maximum being 89 milliseconds, which is pretty low for a website which is serving 100 connections, and all that on my machine, local machine. Well, in a practical setup, a server must be a PV one, but still, we are still clocking around of an impressive 5.4 milliseconds average latency for serving web requests. Now, let's also put NodePP Express to the test. We'll keep the parameters same. We'll run it on localhost 8000, I believe. Yeah, it was 8000 on which it was running. So the results aren't that impressive. It takes around literally 3 seconds for serving a concurrent 100 requests, max being 5 seconds. Well, NodePP Express definitely has got a lot of work to do in terms of optimization and stuff. Well, it's built on NodePP, a different NodePP, obviously not the Recmus NodePP which we saw just now. In order to provide some syntactical sugar, NodePP Express definitely compromised on a lot of performance, but it's definitely a repository under development and we should cut it some slack. Obviously with time things are going to improve. I'll put up link in the description to both of these repositories. You can check them out later after this video ends, and I'll move on with the Flask server which I was talking about. Alright, so this is the Flask app which I've created. Nothing really complicated, but we just added a middleware just as we had NodePP Express application. And this is the test route, this is the default route, and this our server starts with the same exact message but on a different port, 5000. So for this I've created a virtual environment called Flask demo. We'll activate it. So now that I have activated my virtual environment, I'll go ahead and run the Flask server, and the server has started. Now that the server has started, we can check what it's looking like. So it is just hello world, just as our NodePP Express server is already doing, but it's on a different port, 5000. Now let's stress test it. Autocannon at the job once again. So these are the test results. Well, provided the same amount of load, NodePP Express and Flask aren't that far apart in terms of performance. Flask is also taking around 3 seconds of average for serving the requests, as NodePP Express was 2. Flask, well, it took a max of 8 seconds, while our NodePP Express took a max of only around 5 seconds, which is still bad, but not as bad as Flask. So definitely some improvement there for both of you guys, NodePP Express as well as Flask. So web development in C++ is not as far stretch of a dream as you might, or as some people might imagine. There are open source repositories which are definitely really good, and if we talk about NodePP, it is absolutely smoking every web server out there. I seriously do not know if there is any web server which we can expect to have 5.4 milliseconds latency on a decent CPU with 100 concurrent requests. It's really an awesome performance benchmark which is set by NodePP, provided this is such a lightweight library. And mind you, I didn't need to install a single dependency for running NodePP. You obviously can run it without any additional setup on Windows as well. I have tried to make it as easy as possible for the NodePP Express repository, my fork which I'm talking about. You can just check this out, run it on your Windows or Linux machine, and this is expected to work. I'll quickly show a demo of this. But before that, let me close the servers which I had started so that the port is free for starting these on Windows. Now I've cleared all the ports. Let's start NodePP first. We'll have to run the bat files for this because it's Windows after all. So let's cd into NodePP, cd src, and then we'll run m and t, making MPP app. So now that the app is built, it's asking me to provide access. I'll do that. Windows Firewall is blocking this. Now the application is listening on port 8080. I'll head on over to that port 8080, and we see our Node++ application is running from a Windows build. How cool is that? Now let's terminate this and terminate batch job all yes. Let's switch on over to NodePP Express, and well, mostly what needs to be done here is actually pretty much nothing. So we have this build folder which definitely contains the Linux build. We can delete the entire build folder. Well, run the build and run script. That's all it takes. So now that the application is built, now it started on the port localhost 8000. We'll open it, and our application is running from a Windows build which is inside build debug folder server.exe. So definitely I would suggest you all guys to go and check out these two repositories if you're interested in a pet unorthodox web development. If C++ is your thing, go ahead. C++ offers you with a lot of playing ground and a lot of room for experimentation. Let me know what you think of these libraries. Let me know if you like this video. Let me know if you enjoyed this, if you learned something new from this. I'll see you in the next video. Till then, keep on learning, keep on growing, and keep making mistakes. See you. Bye bye.